Dear participants, good morning to everybody. Now this is last day of 2 week AST sponsored Atal FDP on agriculture PV systems and electrical vehicles, pioneering sustainable energy and transportation solutions. Today is the last day, so that I have to give some instruction to the participants. Now I would like to divide the total 50 members into the 5 teams. These 5 teams uh, they have already prepared the slides. Then they have to explain those slides team wise. The team leader or one of the one participant from the team. You have to present your work. So I already given the model presentation. Let me explain once again how we are able to present the uh, your sessions output as well as a field visit, and then I will give some summary of 2 week ASV sponsored Atal FTP on agriculture PV systems and electrical vehicles, pioneering sustainable energy and transportation solutions. Now these are total 50 participants. We divided team number one. Now all of you note already. So I already given this list to the participants. So once again I'm explaining. So the team number one, that is M Chandrasekhar Kumar, Abdul Kalam Sheikh, Gubba Naveen, Venkata Ramana Peram, Arun Yuvraj, Sheikh Rasulullah, Sheikh Allah Bakshu, K. Vimal Kumar, Vattam Sri Divya, Dasari Kiran Sai. Now these 10 members comes under the team number one. Team number two, Motharasu sir, Sheikh Gauss Basha sir, and Kaladar, Sheikh Shakira, B. Venkata Narayana, Ankireddy, Venkataramareddy, Patan Abdul Aisha, Kandipat Rajani, Suresh Mikli. These are team number two. Team number three, Mangalpur Sravani, A. Venkateswara Garu, Jagadish, Dr. Sharif Garu, Gopaya, Satish Kumar Vavalera, Sureka, Uma Hesarao, MD Sharif, M. Ravindra Babu. These are team number three. Team number four, the Rajesh Gargapati, Nagamalleswari, V. Srinivasaraju, Kesana Gopi Krishna, Ramakoteswarrao, G.V. Nagaraju, Annamaya Garu, Vamsi Krishna, Sai Anusha. Team number five, Yamachavaram Suman, S. Srilata, Surya Prabha, Saravanan, K. Venkatesh, Malleswar Rao, Y. Nagendraya, P. Sriramanarayana, Noor Basha, Umayasara. Now, so this 2 week Atal FTP, we have completed 16 sessions. Let me summarize the topics discussed by the various research persons. The first day, Dr. Ravindra Garu, so that taken 2 sessions. The session number one, introduction to the FDP. So the introduction to the agri PV systems, and then development of a civil and mechanical structure for agri PV systems. Second session, specifications of a solar cell model and inverter applications. Here the 2 sessions completed, and then 2 article discussions also completed. Second day, the session number one taken by L.N. Sastri Garu. So the session number one is impact of agri PV systems on farm productivity and sustainability. Second session, overcoming challenges in integration of agri PV systems and EVs. That day also we discussed the 2 article discussions. Third day, so taken by the Dr. V. Sandeep sir. So sir taken 2 sessions. Session number one, that is challenges and opportunities in agri PV systems. Session number two, performance indices of agri PV systems. So the 2 article discussions, that is as a coordinator I discussed the 2 article discussion on that day. that is day 3. The fourth day, the 28th, so the sessions are taken by the Dr. P. Shankar Garu. So the are taken two sessions, theoretical sessions. So the session number 1, technological innovations driving the agri-PV systems and the EV integration. Session number 2, energy storage solution for agri-PV systems and EV. That is the fourth day. So the fifth day, the two sessions are taken by Dr. Ramesh Garu. There is solar power drives for agriculture and PV EV applications. So the SAR explained the different hardware models also. So the to do the research work in the different areas. So the fifth day, so the that is a so the fifth day, so that is I have taken so the one session, that is the present state of agri PV systems. So that is on that day. So the three sessions are completed. So the two sessions are taken by the Dr. T. Ramesh Garu. So the on that day, the third session I have taken. I explained the present status of agri PV systems in India. Next 30th, the two sessions are taken by two sessions are taken by Dr. T. Vinay Kumar Garu. So the first session, Sir had taken the advanced speed control schemes of electrical motor drives for the electrical vehicle applications. So the second session number 2, so the Sir explained the induction motor drives for the EV applications. So the Sir explained the different concepts related to electrical vehicles and the electrical drives. The next one is that is a second day. The second day, that is the two sessions taken by Dr. K. Anil Garu. So the session number 1, the title is farming practices enabled by the PV systems and electrical vehicles. So the session number 2, reducing carbon footprint through the agri PV systems and EV solutions. So the that is a third day. So the that is a for 14th session and 15th session taken by the Dr. Anil Nayak Garu. So the last session, that is the 16th session, I have taken. So that is title is economic feasibility of agriculture PV systems with the electrical vehicles. So the theoretical sessions are completed by that is second December. So after that, we visited four industrial visits. So we visited. Now these are today's schedule. So the 9:30 to 1:30, the team-wise presentation of output. So the next 1:30 to 2 o'clock lunch. So the next one is a reflection journal. 3 to 4 o'clock, you have to give the feedback. So the 4 to 5 is a valedictory session. Now we visited the solar power plant. That is near to the it is so the triplex company. So opposite to the triplex company, so they installed the solar power plant. This is a solar power plant. So that is near to Amravati. So the name of village is Nidamukula. So we visited the solar power plant, the Bharati solar power plant. So there we have seen now the capacity of a solar power plant is 1 megawatt. So they are generating the power by the solar panels. So the output is given to the triplex factory. So there they are doing the lot of work. So for that purpose they need electrical power. So then here we identified the many problems. So under the PV systems, they are not growing any crops. So we suggested that it is better to you, better to use some crops. So therefore the total efficiency is increases. So the next one is it is a old version. The PV system is old version. So therefore, we suggested that it is better to use so the many latest technologies. The upgradation is required. So after that, we visited the substation. So the substation, all the participants, they have taken so the many things. So that is they have seen the circuit breakers, fuses, so the different types of inverters. So the like that they explained. So the this location, that is solar power plant is location. So the in between the what you call, so the very beautiful location. So the there you can see many things. So the many technical details are collected. So the we solved the we connected the issues and possible solutions also. So these are one of the important power plant. Next one is, so the this fellow he is explaining the many things to the participants. So the he explained the inverters, how the panels are connected, how the solar panels are cleaned. So the like that total plant. Okay, so explained by the so this fellow. Next one is we visited for this first power plant, that is a solar power plant. So we visited the Josel also. So the Josel, we have seen the different processes and substation. So the dear participants, now you can view the presentation like this. So that the first one is the sessions. So the 16 sessions, what you have learned. So the what are the important points you have learned. First, so you have to explain the sessions output. So after that we have to give the presentation on field visits. So what are the different problems identified in the field visit? Then try to give the solutions for that, technical solution for that. Now, all of you, give the presentation. So the give the presentation on agri-PV systems in your own words. So these are only I'm giving the how we are able to give the presentation. So this I'm giving the outlines. After that, so the team wise you have to come and present your even in your own words. So just I'm giving the how we are able to present, what are the important points you have to, so they explain like that I'm explaining. After that, you have to come and team wise you have to give the presentation. So here agri PV systems combines the agriculture. Agri-PV systems combines agriculture and solar photovoltaic energy production on the same land to optimize the resources. So this innovation approach addresses the challenges of completing the land requirements for the food production and renewable energy generation. The concept promotes the relation between the farming activities and the solar energy harvesting, enhancing the land productivity and resources. So these are definition you have seen, but you have to give your own words. You have to explain the agri sections. So the next one is the key concepts. So these are dual land use. So the agri systems indicate the agriculture practices. There is a crop cultivation and a livestock grazing with the solar energy production. And the solar are mounted at elevated heights, so with adjustable spacing to the ensure the sufficient sunlight to reach the crops. Now this you have to in your own words explain the what is the shading effect. So the solar panels provide the partial shading which can reduce the heat stress on the crops in the hot climates. So the second one is shading can also help the conserve the soil moisture and reduce the irrigation requirements. So third one is optimized solar panel placement. So the panels are installed in such a way that maximize the solar energy output while minimizing the disruption to the farming activities. So the design includes the fixed and adjustable till, so the tracking system to accommodate various agriculture needs. So in this all of you try to explain in your own words explain the what is the shading effect. So the how to how to what how to effect, how to So avoid the shading effects. Next one is optimization solar planner placement. So the these another so in your own words try to explain so the these points. Next one is crop yield and energy generation. So the certain crops have so the thrive under the shaded conditions, improving their yield. So the solar panels generate the electricity for use on the farm and feeding into the grid, providing an additional income to the stream. Environmental benefits: the reduce the carbon footprint by generating the clean energy, improve the microclimate conditions for the crops and enhance the biodiversity. Water management: panels can capture the rainwater and aiding the irrigation, reduce the evaporation due to the shading contributions to the water conservation. So the like this, so the I explained the so the crop yield and energy generation. So what is the data is required for the crop yield and so the that is the energy generation. So the I explained the one paper. So that is with the simulation. So the try to understand that paper and try to understand the different how to calculate the different parameters. So the performance indices of agri PV systems. So the you have to explain those things also. What in your own words. In your own words. Next one is these are environmental. These are environmental benefits. So the reduces the carbon footprint by generation of clean energy. So improves the microclimate conditions for the crops and enhance the biodiversity. So next one, water management. Panels can capture the rainwater and aiding irrigation. So reduce the evaporation due to the shading contribution to the water conservation. Next one is economic benefits. Dual income from the agriculture and energy production increases the land use efficiency, reduces the energy cost for the farmers, and promotes the sustainable farming practices. So coming to the applications, crop cultivation under the solar panels, that is vegetables, fruits, herbs. So that's in the like that you have to in your area. So the is there any possibility to grow the vegetables under the PV systems? So the next one is livestock grazing under the solar installations. So the agri forestry systems will combine the trees with the solar panels. So the like that you have to explain. Next one is what are the challenges in the agri PV systems? So the in the challenges means high initial cost, so the high capital investment for the solar panel installation. Next one is a design complexity, requires a careful planning to balance a light distribution and the farming needs. So the maintenance of both agriculture and the solar components can be. So the you have to see the what is the maintenance required in your own words you can explain. So the land is specific, not all the crops that the territory are suitable for the agri PV systems. So now these are the challenges. So you have discussed the many research papers. So the in own words. So try to identify so the different challenges in the agri PV systems. So they have to prepare the so the issues and the possible solutions. So the like that you have to explain. And also it is easy. So the many papers so the future scope are emerging trends in the agri PV systems. So the collect I think so most of the participants have collected the so the future directions of agri PV systems, and the research persons also explained so the different directions of agri PV systems. So the try to collect include in your presentation, that is agri PV systems emerging trends. So the first one is dynamic agri PV system. So the in this the mobile solar panels that can adjust the optimize the light for the crops and energy production. So that is a one challenging problem. Next one is integration with smart technologies. So the smart technologies we visited yesterday, we visited the electronics. So there you have seen different types of IoT devices. So which are useful for the agri PV systems also. So next one is the integration with the smarter technology, so IoT and AI for the precision agriculture and energy management. So collaboration with the policymakers, so the incentive for adopting So the agri-PV systems to support renewable energy and sustainable agricultural goals. So agri-PV systems are present win-to-win solution to tackle energy, food, and land use challenges and promoting the sustainable future. So this interesting topic, that is EVs in agriculture. So electrical vehicles are gaining traction in the agriculture. So the way they can provide a sustainable and a cost-effective solution for various farming activities. So coming to the EV applications in the agriculture, so the electric tractors and the machinery. So the electric tractors and machinery are replacing the traditional diesel powered ones. So these machines are quieter and more efficient and produce zero so the tailpipe emissions. So the next one is this includes the autonomous electric tractor for the application of farming, electric seeders and sprayers. So these are the electrical vehicles in agriculture. Next one is these are transportation and logistics. So the EVs such as electric vans, utility vehicles, and so the tractors are used for the transporting the goods, livestock, and agriculture produced within the and outside the farms. So the compact electric vehicles are also used for on-farming logistics like moving supplies and so the harvested crops. So the next one is irrigation systems. The EVs can power the mobile irrigation systems that is allowing farmers to efficiently manage the water usage. The integrated EVs with the solar charged batteries are used for the remote irrigation operations. So these are one of the AP government is also so the giving the training for drones used for agriculture. So the you have to give though it is a this FDP is not related to the drones. So these application the drones are used for agriculture purpose, agriculture applications. So the in the AP they have conducted the one summit. So AP summit, the drones summit. So in that the different types of drones used for agriculture purpose also. So the try to collect those drones related things in the presentation. So electric drones are widely used for aerial monitoring, crop health and assessment and pesticide spreading and field mapping. Integration with renewable energy sources, agri-voltaics combine the EVs with agri-voltaics. So allows the farmers to charge the EVs using the solar energy while benefiting from shade to tolerant crops, on-site charging. So the farmers are equipped with renewable energy sources such as so the wind turbines and solar panels and can establish the charging stations for the EVs and reducing the reliance on these things. So here we have to the many application that is by using the agri PV station you can generate the electrical power. So the more electrical power is generated, that electrical power generation is used for charging the electrical vehicles. So that if you see the our banner, so that there you can see so by using the agri PV system we are generating the power as well as so the crop production. So the power generated by the PV systems is used for charging the electrical vehicles also. So that kind of paper, okay, we discussed the one article discussion. So the try to include the such kind of things also. Now you can see the benefits of electrical vehicles agriculture. So environmental benefits, reduction in the greenhouse gases emission. So compared to the diesel powered one. So the next one is so the benefits of EVs in the agriculture, that is the environmental benefits. So the reduction in the greenhouse gases emissions compared to the diesel power machinery, lower the noise pollution, which is advantageous for the livestock and farm workers. So the next one is you have to include the cost efficiency, the lower operating and maintenance cost due to the fewer moving parts in the electrical vehicles. So the diesel operated vehicles, you have many mechanical parts are there. In the electrical vehicles, the noise is less. So the means that this maintenance is less. The potential savings on the fuel by using the renewable energy sources for charging the electrical vehicle. These types we can include. So the next one is improve the precision and automation. Electrical power systems can integrate the better with the modern precision agriculture technologies such as GPS and IoT for optimized farming operations. The increased efficiency, high torque capabilities of electrical vehicles enhance the performance for the task. So the like the halving the heavy loads. So the next one is the field visit. So the field visit, the four field visits, Bharati Solar Plant 1 megawatt power plant. So there you can there you can identify the land utilization and the site challenges. So what are the issue and what are the possible solution? So the one solution is a suboptimal land use and uneven terrain can reduce the efficiency of a panel installation and maintenance. If this is a issue, then you have to give the solution for this. So they implement the agrivoltaics to combine the solar power generation with agriculture and optimization and land use. So these are one solution. Next one is conduct the regular land so the maintenance to ensure the effective panel placement. So these are one problem we can explain. So the next one is this accumulation of a dust and dirty panels. So this is the solar panel efficiency. So the issue is the accumulation of a dust and dirt and the solar panels can significantly so the reduce the energy output. So if this is a problem, then you have to install the automated the cleaning machine and adapt the regular manual cleaning schedules using the water efficiency methods and use a anti-dust coating on the panels. So the in the Bharati solar plant they are cleaning the solar panels so the weekly. So so they are using the manual cleaning. So the we suggested that it is better to use so the automated cleaning that is one problem we suggested. So after that, under the PV panels, so the grass is growing. So we suggested that it is better to use the one crop under the panels, vegetables and fruits like that. That is a food production can be increased and also and also the power generation. So the whatever the PV panels they are used is outdated technology. So we suggested that so nowadays the many advanced materials. By using the advanced materials, it is possible to increase the efficiency of a solar panels. This one suggestion we identify the problem, that is a old power plant. So therefore we identify the many problems. These are issue. We suggested the some solutions, possible solutions for the Bharati Solar power plant. So the next one is weather, the dependency. So then the weather deficiency. So the variability in the weather conditions such as cloudy days and monsoon leads to the fluctuation in the power generation. So the here the triplex power plant needs the electrical power for the different operations to produce the to increase the output. So the actually without solar power plant, so they told that they are paying the 10 lakhs per month. After installing the solar power plant, so the near to the Triplex company, so that they are now they are paying only 2 lakhs rupees. Means that so they saved about 6 lakhs to 8 lakhs per month. So that is another advantage. So therefore here, so the cloudy days, the power generation is possible. In that case, they are taking so the power from the distribution network they are using. So the here this is the issue. So therefore we suggested that integrating with the battery energy storage systems, so that surplus energy can be used for the during the low generation period. So this suggestion we have given to the Bharati Solar power plant. So next one is the maintenance and the operational challenges. So the here there, so the many problems are identified. So the first one is the maintenance of a panels, inverters, and wiring can be so the resource incentive and prone to the delays in the remote locations. So the here this power plant, so Bharati Solar plant is a old one. So they are not using the any modern technology. That is, it is better to use IoT technology for so the maintenance and operational changes. So the here they are using the lesser skilled persons. So if they recruited the skilled persons, then it is possible to increase the efficiency of a so the solar power plant, and they are going to reduce the bills of a triplex power plant. So in this way you can see the solution for the issues. So the next one is a critical integrity. Solar Bharti solar plant, they are not generating the excess power. So they are utilizing for the generated power for only so their own purpose. So the now so only five acres land as used for so agri PV systems, that is a power generation. So we suggested that the more number of panels and more number of it is only 1 megawatt power plant. So the beside that the many land is there. So if they purchase the land and they implement the PV systems, solar generation, so it is possible to connect the power to the grid also. Okay, so these are one issue we identified with the Bharati solar plant. They given the solution for that. So that now, so the by addressing these challenges with innovative and adaptive solutions, so the Bharati Solar 1 megawatt power plant can enhance its efficiency, sustainability, and the contribution to renewable energy sources. So the dear participants, so the like that you have to explain. So the team wise. So now start with team wise presentation. So the no need to come all. So the from the team number one, team number two. So team wise one lead. So come here and give the presentation your own way.
Good morning to one and all. Myself, Venkat Narayana. I am doing full-time research at Vignan University. Today, I am going to presentation of the outputs from the FDP on agriculture PV systems and electrical vehicles, pioneering to achieve the pioneering sustainability energy and transportation solutions. In that, these are my main presentation outlines. That is the different theoretical sessions, outputs, and field visits output, which you have to get the knowledge from the different theoretical sessions and field visits. I have to discuss that outputs in that presentation. Uh, uh, Mainly, today's researchers mainly focus on the concept of the agri PV systems. That is the main concept of the PV agri system is to optimize the land, to optimize the land usage, to combine the agriculture and the solar PV energy production. In that manner, you can optimize the land utilization. Uh, for that, some of the key concept here is the main key concept of the agri system is dual land usage. Means you can use the land for agriculture purpose as well as for cultivating the plants or different applications like aquaculture also. This in this every if you want to go for any research or any ideology, you first introducing the one of the person. That person is Gersberger and Jastrow. He is introduced the concept of agri PV systems in the year of 1982 on the existence of solar energy conservation and plant cultivation. These are the different types of solar panels. He is used in the different applications. One of the application is open field and greenhouse and different aquaculture purposes. First one is types of materials also. He is differentiates in this journal. If you want to go for any further research, this is the base paper for every researchers. This is the first introduce the prototype model. That person is Akira Nagasimha is introduced the prototype model like this. This one, this one introduced the prototype model in the Japan is introduced in 2004. That is, if you can use that is also patent free public. This is you can use everyone. This model, prototype model. No restrictions in this regard. And in 2013, Ministry of Agriculture, Forestry and Fisheries of Japan issued a notice to permit the conversion of farmland on the basis of certain guidelines. That the guidelines are that feed-in should be feed-in tariff need that is need that must be need the permissions must be it must be removable and yield should be more than the 18% of the region hour. These are the if you wanted to use this agri system, the applications of fisheries, agriculture, forestry, you should follow these guidelines. Then later in 2018, permissions are given to agri PV systems for certain crops. That will be discussed in the later slides. These are the some of the applications used in the agri PV systems in the Japan. The mainly nowadays they are using the under agricultural PV systems. They are mostly focused on the crops on that ginger, like rice, mushrooms, like that. They are mainly focusing on that applications in that agri PV systems. That are the so many advantages. They are also mentioned in these agri PV systems. That you know that agri PV system will increase the income to the farmers. Main focus of the agri PV system is first one is Second one is the increase the profit to the farmers. This is the application isolated location solar pumps. One of the application is water pumping systems. In that solar panels, mainly from the solar panels, you are getting the electrical power. From that power, you can use it to drive the motor, electric motor. From that, you can get the water. That water can be used to grow the crops. These are the different means advantages according to this is a reliable one, cost effective, and this is also main. Nowadays we can main problem is pollution. From that also you can reduce by using this water pumping application. This is the isolated locations. Main what is the main drawback of the farmers nowadays facing is they can generate more vegetables and more crops, whatever it may be. They are finally achieve the production. But the main task is to transport whenever there is no transportation facilities or any challenges there means it should be harvest storage is one of the largest sources of food losses. So you can if you avoid the food losses by using the cold storage systems, that will be some of the also giving the ideology in 2011. That is the main ideology. If you can use this solar, this solar system, PV system used to generate electrical power. That electrical power used to the cold storage applications. Then you can avoid the food losses. These are the main challenges in agri-PV systems uh, uh, faced by the different farmers or different persons. That is the most one of the challenge in agri-PV system is initial cost. This is very high initial cost to install the panels. High capital investment is required to install the panel installation, and it is also very difficult to design the solar agri PV system also, because there is a you need the planning in between the balance of light distribution and the farming needs. It is very if you it is saying very easy to say, but it is very difficult to solve the problem. And one of the also maintenance also one of the problem means uh, maintenance is the one of the main problem because of the especially our countries India, there is most of the farmers are illiterate. For that, they are unable to knowing the adopting this technology. They are not aware of this technology. They are also sometimes scaring of this technology. So maintenance also one of the challenging in agri PV systems. One more is land specific, and land specific means this agri PV system is it is a big challenge to applicable to all the crops. All the crops. It is only nowadays research is going. Still now research is going on. It is only some of the crops only will giving the production. Some of the crops are not giving any production. So you have to give. You have to identify the for a specific land purpose. You have to use specific crop. Then only you get the production. Otherwise, we will not get the production. That is also one of the big challenge in the agri PV systems. These are the for that challenges. Most of the finding the different emerging trends. That is the dynamic agri PV. In that dynamic agri PV, mobile solar panels that can be adjust to optimize the light for the crops and the energy production. This is one of the emerging trend to issue the challenges said. One more is integration with the smart technology. It is to if you can able to integrate the this agri PV system with the smart technology, then you can easy to manage the energy as well as the you can get the precision. Okay. Next one, collaboration with the policy makers. Next one is collaboration with the policy maker. You can if you any if you one of the technologies came means if you provide any subsidies, any incentives, like that only we can most of them can able to adapt the latest technology. Otherwise, they cannot go giving the interest to adapt the new technology. And also you can most fourth one is a very important one. You can using this trend, you can achieve the most of the problems faced by the agri PV systems. That one is agri PV system present a win-win solution to tackle the energy, food and land use challenges, promoting a sustainable future. This is the one of the main emerging trend. This is the EVs in agriculture systems. So one if you nowadays everything modernized vehicle with the electric one, so that is also used in the agriculture PV systems. Is electrical vehicles most applications in EVs in agriculture is electric tractors and machinery. Electric tractors and machinery. So this that includes the autonomous electric tractors for precision farming. If you want to precision farming, you should go for the EVs. Yeah, EVs. Then electrical plus different applications also you are using the electrical EVs that you wanna that are the electric plus and the CDAX and the space. For that applications also you are using the EVs in the agriculture. Transport and logistic. This is also most of the applications where whenever the farmers they are getting the output means production, then that production will be transport to one place to one another place. For that you need most transportation. For that you are using the EV vehicles like vans, utility vehicles, trucks. Uh, Go for good livestock and agriculture produce within or outside the farms. Okay. Next one, and also to move the crops, harvesting crops from one place to another place, we are using the EV vehicles. And also one of the application is irrigation systems. We also use the most of the nowadays research is going on the water pumping systems. Yeah. Uh, in that water pumping, if you use the if you want to use the efficiently manage the water usage, you can use the EVs also in that agriculture. Integrated EVs with the solar charged battery service remote irrigation operations also possible. Next, most nowadays the drones is very important application. Today's also most of the research are going on the drones. The drones are mainly used in the agriculture is health assessment of the crop and how much you will spray the pesticides, how much you can mapping with the field of which type of you can use the crop like that you can that will be monitoring by the drones. That is very big application. This is a very useful application and it will be mostly be trending one drones trending one. This is also very useful. It will be in future it is very broad way can use. And one more is integration with the renewable energy. Integration with the renewable energy. That EV vehicles are used to integrate it with the renewable energy. That is like grid to vehicle, like vehicle to grid. One of the application is here grid is renewable energy. Renewable energy means solar PV systems. From solar PV systems, you can charge the vehicles. Whenever uh, you want to drive the trucks or anything, then you can charge the battery through agri PV systems. Then you can use that EV for the agri PV systems. Then simultaneously you can charging it and further further it will be reducing the burden on the grid system also. Then what are the different benefits in EVs in the agriculture? One of the important is environmental benefits. Environmental benefits is to reduce the carbon emission, and one more is you also reduce the usage of diesel. Diesel also you can use the reduce, but cost efficiency. But present it is not a cost effective, but in future it may be cost efficiency. Will get the cost efficiency because most of the trend move towards the this renewable energy based vehicles, so that you can in future you can generate the more energy from the fuel systems, with the reasonable cost. From that you can improve the precision automation. Everything can improve the using the present technology. You can use the GPS IoT to optimize the farming operations. From that you can increase the efficiency of the agriculture production. These are the last 2 days back we visited that Josil company. Most of in that Josil company, one of the instructor discussed that there are the different issues regarding that Josil industry, and you also discussed those problems, and you asked the what are the different types of problems and how we will overcome that problems with the solutions. This is the different operational issues. One of the operation issue you discussed in the Josil instruction is production time. The main issue is if you equipment failure or unplanned maintenance leads to the production delays. This is the issue faced in the Josil, mainly in the production in the production point of view. Then he'll give the solutions, and you set the solutions. By nowadays everything is, if you use the IoT or data analytics, you can improve the you can predict to the maintenance. Then you can eliminate the equipment failure also. You can give the regular schedule maintenance, and it is very very important to in order to avoid the production downtime. You can train the staff early warning signs of equipment issues. It is very very important. Otherwise you cannot get the production. It will be down the production field unable to follow these three solutions. Next one is quality control issue. That issue is variations in the product quality due to inconsistent raw material supply. Due to inconsistent raw material supply, you are getting the product in inequality. They are suggesting the solution for that. Strengthen the supply relationship and enforce quality checks. What are the different types of incoming raw materials? They are within the standards or not? You must follow that standards. Thereby, you can ensure the consistency of the production. These are the environmental issues faced in the Josil. One of the uh, issue is waste management. That waste management is the improper disposal of byproducts and chemical waste affecting the environment. This is a very very important. This is also one of the social responsibility how we should follow. Otherwise, it may impact our organization also. So for that, they are following some of the solutions. The solutions installed the advanced water treatment systems, and they are converting waste to energy useful by products, and comply strictly with if you are unable to follow everyone should follow the environmental regulations. If you are unable to follow the environmental regulations, it must danger to every company. Next one is air and water pollution. This is also, if you are after getting the every production from the production, you will get the water. you will utilize the water and air. If you unable to treat that in the useful way, if you are using it in the direct, it will be distributed to the water, or any if any smoke or light coming from industries, you will be through getting through it to the environmental, then it will impact on the environment, that will causes deaths also nearby human beings. Uh, One of the third challenge is also the supply chain challenges there. In that raw material price fluctuations, you will use the different methodologies, techniques. By using these methodologies and techniques, you can avoid the all these issues. If you increase the costs for key raw materials like oils and fats, we can use the different technologies are there. If you use that methodologies, you can minimize the material price fluctuations. That methodology you can discuss in different industrial management techniques. For that, they are giving some of the solutions that you have to stabilize the purchase regarding costs, and if you are using the diversified suppliers to reduce the difference on the single side. If you go for the different suppliers, then the redundancy will be increased. If you will depend on the only single person or suppliers, then it may be cause price fluctuations in the raw materials. Next one is transport delays. It is also after getting the production from the any company, you need to transport it to some place where it can be utilized. Uh, in that transport delays, they find the one of the issue reaching the raw materials, delivering finished products. Delay. What is they can monitoring the delay in these systems by using the different systems, by using tracking. If you use the tracking systems, then where is the that delivery system holding on that hold the delivery system, then what are the reasons behind for that delays, then you can proceed further, then you can overcome the delays in transportation. uh, One of the issue also they have discussed with the Josel instructor, that issue is energy efficiency, that is high energy consumption increasing operational cost. High energy consumption that will increases the this operational cost. That is for that they are giving the solutions. Install the energy efficient machine. For that you have to improve the any uh, reduce the any operational cost. You go for the better machinery equipment, then you will go for the best optimizing cost, and monitor every time. You have to monitor and optimize the energy use through the energy management systems. For that energy management system, so many techniques are there, so many methodologies are there. You can adapt the technologies, then you can avoid the you can decrease the operational cost of the any product. This is also labor and workforce issues. If you are thinking this is a small issue, but it is very big issue to tackle the labors at the industries, because you don't know what are the problems, and why they are behind also you don't know. Also that are the human resources also very tackle the human resources also very big challenge. uh, for that they don't know. Most of our Indians are in that industries working are some of them are illiterate, some of them are semi skilled, some of them are skilled. But here the main issue with the problem main we are facing this labors is they are unskilled. They are unable to solve small issues also. They don't know if you are unable to training proper in way, but it will causes the very big risk to the our company. For that, they are giving some of the solutions. For them, you have to conduct the regular trainings and upgrade the skills regarding our industrial need, and collaborate with educational institutes for internship and specialized courses. This is employee retention. This is also one of the big issue. every industry facing. That issues high attention rate affecting the operational efficiency. If you are unable to meet the that employee requirements or employee needs, that company will not work properly. That may be downtime, down the. So for that, you have to provide the good salaries and benefits to the employees, and you have to create the positive environment to the among the different employees also. This is a very important to coordinate the employees. So thank you for your attention.
Okay, sir. Thank you, sir. Thank you, sir. Thank you for presenting the team number two. Now the next team one presentation. చేశారు సార్
పైన ట్రాక్ చేయి పైన వచ్చింది సార్
Naveen sir. Good morning to all the participants and the resource persons and the Vignan Lara, the team members, the Triple department and research scholars who are participating into this Atal FDP program. So on agriculture PV systems on electric vehicles, pioneering sustainable energy and transportation solutions. So it's a really wonderful sessions we have it, and now we are going to have our presentation output. On behalf of the team one, myself Abdul Kalam Sheikh, Associate Professor from Nasropeta Engineering College, and this is a presentation of the output. Sir. Okay. So am I audible? So this is Abdul Kalam from the Nasropeta Engineering College, and behalf of my team one, I am going to presentation the output and what we learned in these 2 weeks of the sessions, even in the uh, indoor and outdoor sessions, and I am going to give the presentation of the output. Uh, So this is timing, and I'm having the team one. The members are we are having the 9 members, and we discussed all the things, and then we finalized the PPT and every presentation, and we took the snaps also. So these are the sessions. Session outdoor we just classified into the indoor and outdoor sessions. And the indoor sessions we are going to have wonderful sessions from the resource person from NIT Allahabad and the NIT AP, and then from the Varanasi and all those things. So these are the pictures we got together with the team members. And then we got the outdoor sessions, and we visited the practical oriented the Josil, and then the solar power plants, and then the biomedic and effortronics and the Evera, the electric vehicles, both of them. Just the few snaps of them we got it for the output, and it is related with the field visits, that is related with the outdoor units which we had it. And now, what we understood from these sessions, in the sense, agri-voltaic cells, that is nothing but the system which is going to be combining with the agriculture with the solar systems together, and then the photovoltaic. That we are having the two different things, the technology into the agriculture. We are having the conventional agriculture procedures so far, and now we are adding. Our main idea is to add these solar power systems to this particular agriculture, the farmers, because being in India, we are having the farmers and the agriculture is the main things in our country. So we are adding the technology into this particular agriculture. So most of the 70% of the people, they are living in the villages, and the main resource for us is it's going to be the agriculture. So this is one of the area which we consider, and we are going to add the agriculture and solar photovoltaic cells. That is nothing but agri-voltaic, that is agri-PV systems which we are going to have. And we discussed so many challenges and what we are going to have this requirement of the food. And whereas coming to day-to-day life, if you can observe, we are going to have there will be lot of things they are going to add. We are not having such an increase in the product in the agriculture sector, but we are going to have the population, it is going to increase. Means the demand and the supply. So we are going to have very lot of lagging will be there. So we are going to have, we are adding some of the technology into that, so that we can balance some of the supply and demand in the agriculture sector. That is the synergetic relationship between the farming activities and the solar energy harvesting, which we are going to consider in this particular concept of agri-PV systems. And now we are going to have what are the key concepts which we learn in this particular dual and use in the sense we are having the integrated the energy system. Here you can observe this particular agri PV system integrating with agriculture means nothing but a crop cultivation and livestock grazing. Livestock grazing in the sense by using the PV panels we are going to have these particular animals also we can be and they can be used for the water supply. So these are the solar panels are mounted. What is meant by this particular dual land use? Means you can use the same land for the power generation and at the same time as a shelter for these particular livestock. There is a crop cultivation and the livestock. So here, just we had some of the snaps for this one. The vegetables, the green leaves, they are going to cultivate under the solar roofs, and the water facilities they are going to get the things. Means shading effects are also there, and the dual land usage is going to be as we can so many towns nearby villages and now they are coming into the real estate business and all those stuff. So we are going to reduce the lands which are available the resources, the cultivation land. So by using these particular things, we can use the dual usage. It will be there, and at the same time, the shades what we are going to have the hot climates. Everyone is facing in the worldwide the global warming. Because of that, we are going to have the extreme in every climate. In winter, extreme winter season and extreme temperature it's going to be, and the floods you can come across in country, every corner of the country. In every month, we used to have these particular floods are there, and even in the Chennai, even in our Vijayawada last few months back, we are having a huge floods they are going to be. So because of this global warming, we are going to get the cultivation land it is reducing. So we are going to use this particular dual usage and the shading effects. Shading effects also comes in the corrosion irrigation system for the requirements during the summer conditions. And then we are going to have the picture, some of them it is going to be, it is the agroforestry. So the forests they are going to make the agricultural lands like this. So this is one of the new concepts, new methodologies they are going to use in the agriculture. So before they used to have the agricultural lands, they are going to have only one crop they are going to maintain. But nowadays we are going to have the multi layers. So now they are having the research, they are having 8-layer farming is there. So being as a faculty and I am going to have some of the cultivation and I am also doing weekend farming. So because of that, I came to know about this one. So some of the things which we are going to have in our own lands also. So multi-layer farming they are going to use. Even the plants, the fruits also there, and at the same time the vegetables. Like that, here you can observe only 2-layer farming, but we are going to have now they are going to have the 5-layer farming also is there. And next, this is going to be the solar power, how they are going to use it. And then in the foreign countries, they are going to have this particular livestock grazing. Livestock grazing in the sense we are going to have these particular animals also, why? Because the farmers and the animals they are having a bond since ancient times. So they are going to have this one. Now the modern technology, if you can observe, this is the ancient things, and here the multi-layer farming. And now we are going to add this technology into that. So they are having the farmhouses and this thing. So for the shelter of this particular livestock, the cows and goats and all those. So here you can observe this particular solar panels they are going to maintain. Means agroforestry they are going to maintain at the same time livestock grazing. So because of that one, they can be having the revenue with these particular cows and milks and all the products, and even the electrical energy what they are going to produce, they will be producing by themselves. That's the advantage of this particular things. So that's what we are going to point this. And here, if you can observe, optimized solar placement. So optimized in the sense, whenever we are going to have this particular technology, we need to utilize them in optimal way. Optimal way in the sense, the best output which we need to get in. So if you are going to install the solar panels in the lands, and it will be occupying more space. For the big farmers, they are having thousands of acres, but whereas coming to the small scale farmers and at the middle age, what they are going to have. So for them, a land is going to be very big issue. So for them, they are going to have this optimization means they are going to have the elevated solar panels, and it will not be affecting them for the normal procedure of the agriculture. Means the tractor movement or anything if they are going to move, it will not be a problem for them. That is nothing but the optimal way how they are going to utilize this particular land which is available for them. So that's what our particular resource persons they pointed out, which is a very good thing which we learned in this one. And design of the fixed tilt adjustable disc means whenever we want to make anything like fixed thing, if it's going to be not is working out, then we are going to have this adjustable tilt and including. So tracking system also is one of the technology that is nothing but maximum power point tracking, which we are going to use it in this solar system. And these solar panels are not at the fixed mount, and then they are going to have the adjustable movement will be there. So that's what it's going to be the advantage. And then crop yielding energy generation means along with the crops, they are going to generate some of the energy which is useful for the revenue generation for the normal farmers they are going to have. And then they are going to use this particular solar energy, what they are going to generate, they are going to utilize for this particular means the crop yield and energy generation and environmental benefits. So everyone is talking about every country, every now it's going to be global warming. But what the actions they are going to take implementation is going to be very less. Now, we are talking about in the Paris, we are going to have this global warming summit a few years back, and then some of the countries they came out like the biggest countries also they are not supporting. Whereas coming to by using these particular solar things, the environment pollution we can reduce and carbon footprints we can be giving for the next generations they are going to come. So that is the one of the things it's going to be. And microclimate condition. This is a very important. Now everyone is using the pesticides for everything. So to yield a more crop or something like so, which is going to start root cause for the lot of cancer and diseases. So they are going. Why? Because they want to meet the demand. They want to get that money. So nowadays, because of that reason, they are going to have this. But we're using this particular improves the microclimate conditions by using this particular what we are going to have this footprints and all those stuff. Now next coming, this is the optimization. I got some of the things. Thanks to our Naveen sir who made these particular photographs and everything. So the things is going to be. And we are going to have this particular thing. Now you can observe here, this is the tracking system for the solar panels. Tracking system for the solar panels, they are going to be not with the fixed lane. Here you can observe the plants are there in between and there will optimization the things is going on. And here you can use all the vegetable crops and the fruits, and it is a multi-layer cropping they are going to use it. And even with the solar tracking systems they are going to have. And here you can observe he is performing a day-to-day agriculture activity with the solar panels, which is not disturbing. Even the tractor also going underneath of that. So that's the main thing we are going to have. This is the design and optimization of solar panel placement. So nowadays in our modern countries they are already implemented, but whenever if you are giving these particular things to other people, it will be benefit for them. So that's one of the advantage of this particular optimization of the solar panels. And now next, if we are going to consider the water management, this is one of the very important thing. Water is the main resource. Now in Indian climate conditions, it's going to be like we are going to have the very floods, or it's going to be the very dry conditions. So extreme things which we are going to get, and we got for every benefit, every loss we are having, these things it's going to be we are going to get with the this particular what we are can call the global warming. So one of the reasons what we are going to get for everything we are going to get it for the reason it is going to be the global warming. So the water management, if you can observe this particular reduce the evaporation of the things, and at the same time we are going to have these economic benefits. Dual income for the agriculture and energy production increases land efficiency and reduce energy cost of the farmers. Why? Because whatever it may be, here you can see sunflower, the crop they are going to maintain, and along with that they are going to have this particular solar panels along with this particular sun. And reproduction of this energy production, it is going to be with this particular grid connection. So he can sell this particular thing also. Along with that, he will get the dual income. One thing with the crop, another one with the what we can say with the grid connected power generation also. So one or another way, indirectly, a farmer before he used to produce only food products, now he can produce the energy also, so that he is serving the nation in a different way as a technical aspect. Now, if you can observe, so this is the energy reduced cost of the farmers. And applications. Applications are concerned. We are going to have this crop cultivation under solar panels like vegetable, fruits, and herbs. Already we discussed about it. livestock grazing. You came to know about this livestock grazing, and then installations and agroforestry system. Already the agriculture things in the like in the farm, in the forest, what we are going to consider. Already we showed some of the pictures for these particular applications of this. So this is already I just discussed. This is the agroforestry system, and then this is the livestock grazing. And now the new technology, what they are going to have is the optimization. Here I missed a slide in that previous one. Now you can observe this is the solar tree, which is occupying a very less space, but it is giving a more energy. This is one of the new technology that solar trees also they are being implemented in this particular solar systems. Okay, that's one of the things. Whereas the challenges, now very different technology, whenever we are going to discuss, there will be challenges will be there. So what are the challenges which we are going to get it? It is nothing but the initial cost. Initial cost is a high capital investment is required for this, and design complexity. So design it's going to be, means thanks to the technology now we are having the, just observe the complexity require careful planning for the balancing the light distribution. Why? Because solar panel in the sense we need to incline in a direction. You don't want to install you as you wish. Okay, any direction I can put it. But now they are going to overcome with the by using this particular solar and maintenance. This is a very important thing. Maintenance is going to be very difficult task for a farmer. So he has to do his agriculture day-to-day activities. Along with that, additionally, he has to do this particular maintenance activities. That's one of the main drawback of this particular. So the burden will be very high when we are going, but the benefits also more. But these are the main things. So at what we discussed, we have the brainstorming session, and then we discussed finally what are all the challenges in agri PV system. And one of the things it's going to be the land specific. This is nothing but land specific. Not all crops are the terrains are the suitable for the agri PV system. Why? Because enormous heat is going to be developed underneath of that particular PV system. Every crop you cannot maintain the things. So because that's a main drawback of this particular land specific. And the fertility of that particular lands is going to be, so that's the main thing which we are going to consider. Okay. Next, emerging trends. Okay, what are the emerging trends which we are going to get in? Now the challenges we understood, and now what are the emerging trends? That is nothing but it is a dynamic agri PV. That is nothing but moving solar panels that can be adjusted to optimize the light for the crops. That's one of the new technology they are going to have. And integration with the smart technology. That is nothing but IoT and then the cloud computing and this particular artificial intelligence for the precision agriculture farming. If they are going to use this one, integration with the smart technology. That's one of the new concept which we need to understand. And the collaboration with the policymakers. That is nothing but who will come to this with the huge investments and that. So what we need to do is the policymakers, some incentives we need to give to the who is going to adopt this particular agri PV system to support the renewable energy systems and sustainable agriculture goals. Some sort of from the central government as well as from the state government, we need to get some of the things what we are can have. That's one of the collaboration with the policymakers. It's going to give the benefits to the what we can call to this particular those who are implementing this agri PV system. That's one of the things. And obviously, agri PV system is a present win-to-win solution, and it tackle energy, food, and land usage challenges, and promoting sustainable future. That's the main thing which is going to be one of the prominent technology. Now it is this is just what we understood from this resource persons lectures and all the stuff that is related to the agri PV systems. Now we are moving to the second thing. It is going to be the EVs in agriculture. This is the second topic which is covered in this particular thing. So I would like to thank Sarita madam who is giving the inputs for this EVs in agriculture system. So what we are going to have, that's the electric vehicles. What we are going to use it here in the electric vehicles. If you can observe this particular electric vehicles, now the drone technology you can call it, and the harvesting with the solar panel with this particular vehicles. What we is going to be without any power, what we diesel or non-renewable energy sources. So just let's see this particular EV in agriculture system. So we are going to have this particular electrical vehicles are gaining the traction agriculture where they can provide sustainable, cost-effective, and the solutions for various farming activities. So that's one of the important thing which we have considered. And the applications, what we are going to use. Okay, if the agriculture in the sense before they used to have these bullocks and all the carts and all. Now the technology is coming to the picture, then it's going to be the tractor they are going to use. Now the tractor also we are going to use the electric vehicles. That's one of the advantage of this particular electric traction. That is the diesel power, traditional diesel powered ones is replaced with this electric power. That is nothing but autonomous electric tractor and electric powers and seeder sprayers and then these drones also. Here you can observe these particular electric vehicles they are going to be. And these are the NAS excavator and all those stuff. Now they are replaced with these electric vehicles. So all the works which are carried out with these JCBs and all, now they are going to come up with the electric vehicles. So one of the advantage. Just as we got some of the comparison for the normal electric tractor and then 20 kilowatts electric motor tractor. So here if you can observe, there is a 40 HP diesel tractor which is equivalent to 20 kilowatt electric tractor and the cost for the tractor is just 7 lakhs and it costs around 12 lakhs. So now the initial cost is going to be very high and the down payment, okay, let's say I'm just taking 1.5 lakhs for the down payment of this and 1 or 2 lakhs for the down payment of this particular electric tractor. EMI is concerned, we are going to have monthly 12,000 I'm paying and 21,000 let's say. And the diesel 6 liters and if I'm taking 6 liters and we are going to have per hour and 15 days average I am going to take and per month I am going to it cost me 27,000. Whereas for the battery charging at the rate of 20 units I am going to consider, it costs me for 1 month, it is going to be 2,100. Means it is 27,000 per month and it is going to be 2,100. It's not with our only one crop and let's say imagine like the tractor is working for around 100 acres in that land, okay. So you may have a doubt like every day we will not use this tractor or something like, okay. By assuming the things, the maintenance etc we are going to have let's say 1,000 and the maintenance cost is going to be 3,900. Battery replacement cost after the 4.7.11 and miscellaneous cost, total cost per month if you can consider 43,900 and it is going to be 32,000. Let's say cost per year if you can consider, if you are going to use a diesel tractor, 5,26,800 it will cost, whereas the electric tractor it will cost you 3,86,500. And total, if you can observe total cost per year and 5 years of life if you can consider, it cost me 26 lakhs 34,000 for this diesel tractor, whereas coming to this electric tractor, it is going to be 19 lakhs 32,000. Means the net savings if you can consider, in between you are going to have the 7 lakhs difference is there. Now coming to the overall savings if you can consider, 27% of the income you can save it by using this electric vehicle. Yes, initially if you can think, it is going to be 12,000. 12 lakhs and it is going to be 7 lakhs. So everyone will think, okay, here I am going to spend around 5 lakhs rupees extra. Why I have to pay? But yeah, I will suggest like if you want to do farming only for 2 years, after that you are going to stop it, then it's better you can go for the diesel tractor. But if you are having the vision like you can continue with that, as we are having the farmers, they are giving their entire life for that farming only. So for them, they are not going to stop after the 5 years. So I will suggest for them 20 kilowatts. Though it is initially it's a little bit high, just go for this one so that you can save 27% of the thing. Means it's the same like solar panels buyback period if you can consider. After the 5 years, you can get the things. And anyhow, you are not going to stop the agriculture, farming, and everything after the 5 years. So best you can use it. Whereas coming to the government sectors, the policy makers, if you can consider, if they are giving some sort of support, some subsidy for these particular vehicles, so that it will be very useful for them. That's one of the thing. Just as our team, they want to put this one also an example. So just we consider this example. Now coming to the transport system, even in the not only with the agriculture works, they are going to consider. Now they are going to come up with this particular what we can say the electric vehicles. They are going to use it for the transportation also. Now before they are going to have these particular vehicles, now they are going to have these electric vehicles, all the goods carriers and everything. Now, thanks to the technology, EVs such as electric vans, utility vehicles, and then the trucks are used for the transporting goods stock and livestock, whatever it may be the purposes they are going to have. So these compact electric vehicles are used for the logistics like moving suppliers and harvested crops to the markets and everything. Why? Because Without them, if they are going to use it, the normal vehicles, it will cost them a very huge thing. Now, this is one of the advantage of this by using this transport. Now, coming to the agriculture irrigation, how they are going to irrigate this particular, you can observe here in this particular, we are having the solar panels and then we are going to have the drip cultivation and it is the 5 layer farming. If you can observe closely, here we are having one crop and on the top you are going to have another crop and here you can observe this is going to be another crop we are going to do, in between you are going to have another crop. So means they are going to use a multi-layer farming by using this particular renewable energy sources. In olden days, the traditional methods, it's going to one person is sitting on the wheels and the, like a pelter wheel, they are going to move it with the legs and everything. Now they are going to have the movable, the solar-based vehicles they are going to have. So here, if you can consider even the machines, they are going to use it for the cut or the things, the field, paddy crop, they are going to use it with the electric vehicles. That's one of the important thing. Integration with EV with the solar charged batteries are used for remote irrigation system. Now you may ask a doubt like what it will happen if we are going to use the electric vehicles, how we need to charge them. But the fields which are there very far away and there is no electrical energy. For them, the best solution is go for the agriculture PV systems, where they will be using the power what they are generating, they are using for the charging of their own vehicles also. That's one of the important. Now coming to the technology, thanks to the technology, now they are going to have a very good thing is going to be drone. So there is drone they are going to use for the sprinkling the pest control and then to take the survey of that particular lands and everything, how, what are the things, and these are widely used. Now it is coming with a lot of things. The pest, some of the chemicals they are going to use, it's very, very bad for the farmer's health point of view. In these conditions, you can use the drones, which is going to be very effective manner for the different crops they are going to be. Now it's going to be they are taking around 500 rupees for 1 acre for spraying this particular by using the drones. Now the cost is coming. Before they are going to charge 800. Now because of the competition, it came to the 500. Now, if you are asking a person to do that, 800 rupees he is charging as the for 1 acre land if they are going to. Being a farmer, I know these particular prices. Now we are utilizing these particular drones technologies so that it is reducing the cost and they are charging around 300 rupees per 1 acre. So entire thing they will be coming and the time also is very less. And there will be some of the pest control which we need to use in the early mornings so that the time scheduling and if you are having a manpower, then it will be a difficult task. Whereas coming to the time will be reduced and at the same time you can use it for the around 20 liters of the can also they are going to take the things. So that's one of the advantages of this. And irrigation with renewable energy. This is very important things what we are going to consider. Now, till now we discussed about the PV agri PV systems, and then we are going to have this particular EVs. Now we are the idea is to club these two technologies. Like we are using the solar energy in the agriculture, and then we are having the electric vehicles. So if you are both of them, they will be combining. It is nothing but the integration with the renewable energy. That is nothing but agri-voltaic systems. That is nothing but combining EVs with agri-voltaic system means it's nothing but we are going to have the on-site charging. On-site charging is nothing but the farmers they are producing the solar energy and these solar energy they are going to utilize for charging these electric vehicles, the tractors you can call or you can call the drones or you can call any equipment they are going to use it. That's the main technology, the integration and the integration it should be in an optimized way. That's the main thing. PV agri systems along with the EV systems. If you are combining these two agri-voltaic systems in the, and on-site charging, they are going to use it. So they are going to have this particular. Here you can observe we are going to have the wind turbine and solar energy, and then they are charging the things. So solar panels, and here you can observe the solar panels are there, and even in the agriculture is there, and then they are charging the tractors and there will be movable that solar panels they are going to put it on the vehicle and then they are going to charge the vehicle and at the same time they are doing the agriculture. That's one of the technology what we are going to observe this. Now benefits, what are the benefits of EVs in agriculture system? If you can observe that environmental benefits in the sense it is going to be that particular greenhouse gases if you can have it and then compared with the diesel things, and the lower noise, if you can, noise pollution will be less, and then the cost efficiency, that nothing but lower operating maintenance costs. But as we promised, that initially high amount you need to be kept particular agriculture. That's the main thing drawback. But the cost efficiency, operating cost and running cost, maintenance cost, and then the potential savings on fuel, it is going to be very less. So that's the main objective of this particular benefits of EV in agriculture. And then we are going to have this particular improved precision and automation. That is nothing but the GPS and IoT, and they can have with the control over all the things, so that they can be utilizing this integrator compared with the traditional agriculture. Now increased efficiency. Now they are going to have this high torque capabilities of EVs. So for any agriculture purpose, for the transportation, it's okay. You can maintain with the normal torques. But whereas coming to this particular high torques are required during this particular what we can say agriculture purpose. So these particular EVs, they will be useful for that what we can say agriculture. High torque capabilities of EVs, it is going to be very good thing, very good thing if you can observe. Okay, so that's one of the important thing. So far we discussed something related with our what we can say PV agri PV system and then the EV system, and we are integrating both of them. That's the thing which we learned from this particular 2 weeks Atal FDP. And then we are having a very interesting part, and we have very good fun during the field visits. So we visited the power plants, and at the same time effortronics are there, then we are going to have. So this is one of the case study. Along with my team, just we discussed related with Bharati Solar 1 megawatt power plant. It is nearby Amravati, our capital of Andhra Pradesh. It is in Endroy. So just we had it, we visited, and we along with the team just we discussed. There are some of the issues which we come across with this particular solar power plant, our notice, and then we make some of the solutions after the discussion. So what the issue, first issue what we are having, it is nothing but it is located in some uneven areas. So because of that reason, we are not having that particular efficiency of the panel installation is going to be reduced. So what we suggest for the solution is that like what employ agrivoltaics to combine the solar power generation with agriculture, optimizing land usage, something like. Now they are going to use only the solar power plant. They are going to have a lot of space they are wasting. So we suggested them to go with the agrivoltaic system to combine the agriculture with the solar power generation. At least they can plant some of the trees or something like, so which is going to be yield some of the, what we can say fruits, another source of energy without any chemicals. There is nothing but organic things they can maintain. So that's the thing which we suggested. And before they are going to implement, if they are making the area, it's going to be smooth surface, then it will be good. And then we second the thing which we identified is nothing but panel efficiency. So the panel efficiency is going to be located in the remote area, and nearby lot of pressures are there. So this that stone crushing machines and everything. Because of that complete pollution, it's going to be coming up on the panels. They are not maintained properly. So upon our visit, just we discussed, and then along with my team, we just suggested there will be some anti-dust coating on the panels. It will be, or another one, the automated cleaning systems they need to adopt. Generally, they are using the manual cleaning, but it costs them very high, and some of them they will be not cleaned properly. Some of the areas which we are not observing, and some of the things it's going to be for them. Just we suggested to go with the automated cleaning system so that it will be very useful. Now in India also we are going to have a separate solar panel cleaning tractor also. It's available nowadays. Just we communicated with them. So that's another point which we identified. Now the thing is going to be again, for every problems in the earth, we will be blaming only the what we can say global warming. So weather dependence. So here it's we don't know when the rain will come and when it will be sunny, and every day we will be observing three conditions. Before, while we are in childhood, we used to have winter is this month from this time to this time, and summer is from this time to this time. But here we can observe the very hot sun and every winter season, and at the same time in the morning it's rain. Means 3 seasons in a day. It's something like different. We cannot predict something like the weather conditions nowadays. It's power. We cannot do anything for the weather conditions until unless everyone is come across with this particular global warming. So that's the main thing. So this particular solar power plant, they are having, they come across with the variable weather conditions, cloudy days and monsoons, fluctuating of the power generation. They come up with this thing. What we suggested in the sense technically, we suggested like integrate with the battery energy storage system, that is the BES, to store surplus energy for during usage of low generation period, and something like hybrid systems incorporate with this. Why? Because solar power plant will work only for the 12 hours, and other 12 hours we need to have this particular another source of energy. We used to have this particular what we say, the battery sinks which we need to install, or otherwise they can be installing as it is located in the hilly area. So along with the wind speed, by measuring the wind speed, they can install some of the wind turbines also, so that it will be useful for them. That's one of the suggestion what we observed. Or otherwise, nearby there will be lot of, we observed nearby areas lot of agriculture based and thing it is there. So we identified we can use start a biomass plant also nearby with the small scales, so that it will be useful for them to generate the electrical energy. That's the third thing which we observe. And now fourth one, which is going to be the maintenance of the panels and the inverters, and wiring can be resource intervention and prone to delays in the remote location. So for that, thanks to the technology, IoT based and the GPS based and remotely track performance, employed local skilled labor for the faster and means the training, the continuous training. You need to be local. You need to make the local skilled labor so that they can be on-site response to the operational issues and all. So that this is the another one. But because it's located, our capital is not fully constructed, so that we are having its remotely located, so we are having these issues we identified. And now the fifth one, it is going to be grid connectivity issues. So inadequate and reliable grid connectivity in rural areas is the hinder transfer for the power generation. So then they are going to have the upgrade the infrastructure of the collaboration with the local utilities. And then the best option for this one is that thanks to the technology, now we are having the microgrid system. So if they are maintaining the microgrid system with the neighbors and what are the small power plants, what they are going to come across, so that it will be a solution for these particular things which we are. Now, coming to the final conclusion, by addressing these challenges with the innovative and adaptive solutions of the Bharati Solar 1 megawatt power plant can enhance its efficiency and sustainability and contribution to the renewable energy mix. So this, we visited so many, what we can say, locations, but we considered only one thing, that is a Bharati power plant we considered, solar 1 megawatt power plant, and then what we observed it as a team, because before itself they told you need to identify some of the problems what they are facing, and being a technical thing, so you need to support. So that's the main thing which we need to consider. This is by addressing the challenges with this. So this is the final conclusion of our reports, and I'm having thanks to the team. So really they contributed all the things. So before going to that, if we are having a kid in our home and he is crying, a small kid who cannot talk, month's baby, if he is crying, everyone will feel like, okay, he will get so much pain. What happened? Something problem with the eye, problem with the ear, why stomach or something like. And at the same time, if some other baby, neighbor's baby is crying, month's baby, so but we will feel like poor or something, like why they are doing like this, why they are not taking care of, and it's a disturbance for us. So a common thing, it is going to be a kids cry, month's baby cry, but how we are react. That's the main thing which we need to answer. So my main thing what I would like to tell you is, until unless if you are having the change, I need to do something from your heart. It will be, we will be living in the developing country like this one. Everyone should be come up with the things like, it's my own country, I need to do something for my country, and I need to maintain the things like technology to the farmers. So it is not something like only educational institute they will be performing, or some of the areas people who are taking the salaries they have to do. Everyone is should come up with the solutions. If it's my responsibility. So until unless we never have any changes. But slowly we can observe on the roads itself. Now the electric vehicles, electric thing is going to be come up with the thing. And soon we will be seeing there is no diesel in our electric means petrol pumps and soon we will be having along instead of the power stations means we are instead of these petrol stations we used to have the power stations means the charging stations so hope, and I would like to thanks to all the ACG and Atal FDP. Really, it's a very wonderful program by the central government. I'm thanking each and every person who is sitting in the central level to the and whereas coming to the local, I would like to thanks to the VLIT management and VLIT principal, Vignan Sadara Institute of Technology principal sir, and AAA department HOD Sharif sir and all the staff members. And then we are going to have special thanks to our Jai Babu sir, who is really timely updating and synchronizing all the departments, even from the starting from the transport to driver to attender to everyone. So for hosting such an event, and if our FDP colleagues and the students and student volunteers and non-teaching staff of VLIT. Okay, thanks sir. Thank you for your cooperation and attention. Thank you sir. Okay, so now so we'll have the another session.
Thank you, sir. Thank you for presenting the team to presentation. Now we start team 3. Now the team 3 will present now.
Good morning to one and all. I am Dr. SKMD Sharif, Professor Nashapata Engineering College and head of the department. I would like to present Team 3 presentation. So here the presentation outlines are sections and output and field visits and outputs. And the first one is agri-politics. Agri-PV systems are engaged to interact solar energy generation with agriculture practice on the same land. Below are the technical aspects and design considerations that ensure their efficiency and practicality. So system components. We are having two types of PV panels. And the first one is the semi-transparent PV panel used for the better light distribution, and the biofuel PV panel for capturing light from the both sides. And the power rating of PV panel is from 250 watts to 6000 watts per panel. And the tilt angles are optimized based on the latitude and crop requirements. Standard PV panels are monoclinic and lines are the standard PV panels. Along that one, we are having mountain structures, and the elevated frames are height typically 2 to 4 meters per tractor axis, and single axis or dual axis tractors, and increase the solar energy capture by 10 to 30%, and fixed tilt systems are economically but less efficient compared to the tracking system, and along with inverters and power electronics. We are having the inverters are mostly used for the conversion of DC to AC supply, and the DC will be from the PV panel, and we will fed it to the AC grid for frame use. Equipped with the maximum PPT, MPPT for the maximum efficiency, and this MPPT is used to tracking the maximum power point, tracking point where the solar is very good, and energy storage. Normally they use battery for the DC storage, and we are having battery system for off-grid frame or nighttime use, and technology used for the batteries are lithium-ion, lead-acid or flow batteries, and monitoring systems are sensor for soil moisture and temperature and light intensity, IoT-enabled systems for real-time data collection and system control. These are the energy storage and monitoring system. And the next one is land usage optimization. So we are having panel arrangement, shading management, and crop selection. Panel arrangement having row spacing of 8 to 12 meters to ensure sufficient sunlight for crop, and orientation east to west for uniform shading, north south for optimal solar energy, and shading management are panels are designed to allow particle shading, and adjustable tilt system can be modulated shaded level to balance energy and crop needs, and crop sections are the shaded tolerant crops such as vegetable and fruits and other medical plants and fooders. And the next one is the electrical specifications. PV system size will be varies from a few kilowatts for small farms to megawatt scale for large operation. Voltage levels are the low for low voltages up to 1 kilovolt for small system, and medium voltage from 11 to 33 kV for grid connected setups. Efficiency, overall system efficiency will be from 15 to 20% depending upon the technology. And the next one is water management system. Irrigation system, drip or sprinkler system, integrated PV structures are used for irrigation system, and rainwater harvesting and collection through the tilt panels or storage underground or above ground tanks for the water management irrigation. And the next one is climatic considerations. For the wind loads, structures must be designed to withstand local wind speed from local wind speed. For the example, IEEE 614,000 standards. And the temperature, elevated panels reduce ground temperature, creating cooler micro climate for crops, and heat resistant crops are selected for high temperature regions. And the next one is environmental impacts. For we are having dual usage efficiency and land usage efficiency and carbon offsets. Dual usage efficiency will be measured for the combined efficiency of energy production and crop yields. And land usage will be typically 60 to 80% higher compared to the standalone system. And carbon offsets reduced in CO2 emissions due to the renewable energy generation. And the next one is standard guidelines for IEC. First one is the IEC 61730 for PV module safety, and IEC 62817 for PV tracking system. Agriculture guidelines are the adoption to local farming practice and climatic condition. And the next one is EVs in agriculture. So these are the some applications in EV. First one is the electrical tractor and machinery. Electrical tractors or machinery are replaced with traditional diesel powered ones. These machines are quite more efficiently and produce zero tailpipe emissions. Examples are the automated electrical tractors for farming and electrical plows, seeders and sprayers. And the next one is the transport and logistics. EVs such as electric vans, utility vehicles and trucks are used for transportation goods, livestock and agriculture produce within the outside frames. And next one is the compact electrical vehicles are also used for on-framing logistics like moving supplies or harvest crops. And the next one is irrigation system. EV can power mobile irrigation system, allowing farmers so efficiently manage water usage. Integrated EVs with solar charged batteries are used for remote irrigation operations. And the next one is drones. So electrical drones are widely used for aerial monitoring and crop health assistance and pesticide spraying and field mapping. and irrigation with renewable energy. Agrovoltaic systems combine EV with agriculture allows farmers to charge EVs using solar energy while benefiting from shaded tolerant crops. And on-site charging frames equipped with renewable energy sources such as wind turbines or solar panels can be established charging station for EVs, reducing reliance on grid electricity. And the next one is benefits of EV in agriculture. Environmental benefits, reduction in greenhouse gases and emission compared to the diesel powered machinery and low noise pollution. And cost efficiency, lower operating and maintenance cost due to the few moving parts in EVs. And the next one is improved precision automation. Electrical power system can be integrated better with modern precision agriculture technologies such as GPS and IoTs for optimizer farming operation. And the next one is increased efficiency. High torque capabilities of EV enhance performance for tasks like plowing or hauling heavy loads. And the next one is field visit for Evera, and this one is the Veera EV near Nunna, which is located near Vijayawada. Is company likely involved in the development of distribution of electrical EVs as emerging sector in the EV industry to face various challenges. And here the issues are first one supply chain and component production. First one issue is the storage of raw materials. EV requires key materials such as lithium, cobalt, and nickel for batteries, which might be challenging to source. And logistics challenges are the distribution delays in acquiring critical components, especially for international markets. For this, the solution is local sourcing. Identify and establish a relationship with the local suppliers for component to reduce dependency on imports and diversity of supply chain. Build a device supply chain to migrate risk related to raw materials shortages and stock management. Implement real-time monitoring of parts and raw materials to forecast demanding and reduce stockouts. And the next one is charging infrastructure. So here the second issue is the lack of charging stations and slow charging time. So lack of charging station in insufficient public charging infrastructures near Nunna, making EV adoption slower and slow charging time. Users may be discouraged by long charging time at the public stations. And the solution is collaboration with the local governments. Work with the state and local authorities to set up EV charging station at locations like highways, shopping malls, and residential areas, and partnership with energy providers. Partners with renewable energy sources, solar or wind, to provide charging station and fast charging solution. Invest in ultra fast charging technology to reduce charging time for consumers. And the third issue is the market competition. Issue is the increasing competition as EV market goes. Everywhere might be face intense competition from the domestic and international EV manufacturers. Solution is the product differentiation and customer centric approach and brand loyalty. First one is production differentiation. Focus on unique selling points, USPs like vehicle range, battery life, environment design, or added features. And the customer centric approaches focus on after sales services and affordable pricing strategies. And brand loyalty is strengthened brand value through customer engagement, feedback loops, and community building initiatives. And next issue is the technology and research. Issue is the battery technology. High cost and limitations in energy destiny of current battery technology, which affects range and cost. Solution is the invest in research and development. And second one is the adopt alternative materials. And third one is the battery leasing model. And invest in research and development is the collaboration with the research institutions or university to advance battery technology and adopt alternative materials. Explore battery alternatives like solid state batteries or graphite battery based solution. And battery leasing model. Introduce a battery leasing or swap model to reduce the initial vehicle cost and address battery long conference. And the next issue is the consumer awareness and adoption. The issue is the lack of awareness and range of anxiety. Many potential customers in Nunna may be unaware of benefits and availabilities of EVs and the range. Consumer may be hesitant to switch to EV due to concurrence over driving range and charging infrastructure. And solution: educational campaigns, test drives, and range extension solutions. Educational campaigns: conduct marketing campaigns, workshops, and road shows to raise awareness about EVs, and test drive programs. Offer potential customers free test drives to allow them to experience EV range. Provide vehicle range infrastructure clearly, and offer solutions like range options or battery swapping stations. And the next issue is the regularity and policy changes. Issue is the policy uncertainty. Lack of constant policies or incentives from the government of EV manufacturers and consumers. And the solution is engage with the government bodies, work closely with the government agency to advocate for better EV related policies and subsidies and intensities. Subsidy and tax benefits are lobby for tax rebates, production incentives, and infrastructure support to make EV more affordable for consumers and manufacturers. The next one is compliance and with the standards. Ensure that Avera EV meets all local, national, and international regulations for vehicle safety, emission, and performance. And the next one is the customer support and service. Issue is the limited service centers, lack of sufficient service centers and maintenance centers for EV near Nunna. And solution: expansion of service centers and mobile service unit training and certification. First one is expansion. Establish more authorized service centers, especially in semi-urban and rural areas. Mobile service units offer mobile service are door-to-door pickup service to assist the consumers in remote areas. And the next one is the training and certification. Train local technicians to provide high quality service for EV and their complexity system. And the next one is by addressing this issue, particularly area EV can optimize its operations, enhance consumer trust, and accelerate the adoption of EVs in region around Nunna. And thank you for your attention. And I am thanking you to Vignan Lara for giving this opportunity. Thank you.
So thank you, sir. Thank you for presenting your work. So now the team 5 presentation starts now.
దాంట్లో వైట్ ల్యాప్టాప్ డిస్ప్లే ఏజ్ డిస్ప్లే అయిపోతుంది
Good morning, all of you. My name is Sarita. I am from Team 5. So I am going to tell about the sessions output and the field visits output. Next, this is the agro voltaics. Agri PV systems are engineered to integrate solar energy generation with agriculture practices on the same land. So these are the system components. First one is photovoltaic panels. There are the types. First one is the semi-transparent PV panels for better light distribution. Next one is bifacial PV panels for capturing light from both sides. And the power rating is typically range from 250 watts to 600 watts per panel. Next, tilt angle is optimized based on latitude and crop requirements. Standard PV panels. Next one. Mounting structures. Elevated frames. Height is 2 to 4 meters for tractor access and single axis or dual axis trackers. Next, inverters and power electronics. Inverter is used to convert DC from PV panels to AC for grid or farm use. Equipped with maximum power point tracking for efficiency. Next, energy storage. Battery systems for off-grid farms or nighttime use. Technologies, lithium ion, lead acid or flow batteries. Monitoring systems, sensors for soil moisture, temperature and light intensity. IoT enabled systems for real-time data collection and system control. Next, land use optimization. Uh, Panel arrangement, row spacing is 8 to 12 meters to ensure sufficient sunlight for crops. Orientation is east to west for uniform shading, north south for optimal solar energy. Next, shading management. Panels are designed to allow partial shading. Next, crop selection. Vegetables, fruits and other medicine plants and fodder. Next, electrical specifications. PV system size varies from few kilowatts for small farms to megawatts. Voltage levels. Low voltage for small systems, medium voltage 11 to 33 kV for grid connected setups. Efficiency, overall system efficiency is typically around 15 to 20% depending on the technology. Next, water management integration. Integration, drip or sprinkle systems integrated with the PV structures. And also rainwater harvestings, collection through tilted panels, storage in underground or above grounded tanks. Next, climatic considerations. Wind loads. Structures must be designed to withstand local and speeds. Next, temperature. Elevated panels reduce ground temperature, creating a cooler microclimate for crops. Heat resistant crops are selected for high temperature regions. Next one is environmental impact. Dual use efficiency. Measure of the combined efficiency of energy production and crop yield. Land use efficiency is typically 60 to 80% higher compared to standalone systems. Carbon offset. Reduction in CO2 emissions due to renewable energy generation. Next, IEC standards, IEC 61730 for PV module safety, IEC 62817 for PV tracking system. Agriculture guidelines are the adaptation to local farming practices and climatic conditions. Next, EVs in agriculture. Electric vehicles are gaining traction in agriculture where they can provide sustainable and cost-effective solutions for various farming activities. Applications of EVs in agriculture. First one is electric tractors and machinery. Electric tractors and machinery are replacing traditional diesel-powered ones. These machines are quieter, more efficient, and produce zero tailpipe emissions. Examples: autonomous electric tractors for and also electric floors. Transports and logistics. EVs such as electric vans, utility vehicles, and trucks are used for transporting goods. Next, irrigation systems. EVs can power mobile irrigation systems, allowing a farmer to efficiently manage water usage. Integrated EVs with solar charging batteries are used for remote irrigation operations. And also drones. Electric drones are widely used for aerial monitoring, crop health assessment, and pesticide spraying and field mapping. Next, integration with the renewable energy. Agrovoltaic systems combining with EVs with agrovoltaic allows farmers to charge EVs using solar energy while benefiting from shade-tolerant crops. And also on-siting charge. Farms equipped with renewable energy sources such as wind turbines or solar panels can establish charging stations for EVs, reducing reliance on grid electricity. Next, benefits of EVs in agriculture. Environmental, first one is environmental benefits. Reduction in greenhouse gas emissions compared to diesel-powered machines. Lower noise pollution, which is advantageous for livestock and farm workers. Second one is cost efficiency. Lower operating and maintenance costs due to fewer moving parts in EVs. Potential savings on fuel by using renewable energy for charging. And third one is improved precision and automation. Electric power systems can integrate better with the modern precision agriculture technologies such as GPS and IoT for optimized farming operations. And fourth one is increased efficiency. High torque capabilities of EVs enhance performance for tasks like plowing for or hauling heavy loads. Next, one of the field visit Avera company. It is located near Nunna. Is a company like involved in the development or distribution of electric vehicles. First one is supply chain and component procurement. Shortage of raw materials. EVs require key materials such as lithium, cobalt, and nickel for batteries, which might be challenging to source. Second one is logistical challenge. Distribution delays in acquiring critical components, especially from international markets. For that solution is local sourcing. Identify and establish relationship with the local suppliers for components to reduce dependency on imports. Next one is diversified supply chain. Build a diversified supply chain to mitigate risk related to raw material shortage. Stock management. Third one is stock management. Implement real-time monitoring of parts and raw materials to forecast demand and reduce stock out. Next, charging infrastructure. Issue is lack of charging stations. Insufficient public charging infrastructures near Luna. Marketing EV adoption slower. Slow charging time. Users may be discouraged by long charging times at public stations. Solution is collaboration with the local government and also partnership with energy providers and fast charging solution. Next, market competition. Issue is increasing competition. As the EV market grows, Avera EV might face intense competition from other domestic and international EV manufacturers. Solution is product differentiation and customer-centric approach and brand loyalty. Technology and research. Issue is battery technology. High cost and limitations in energy density of current battery technology, which affects range and cost. Solution invent in research and development, adapt alternative materials, and battery leasing model. Next, fifth one is consumer awareness and adoption. Issue is lack of awareness. Many potential customers in Luna may be unaware of the benefits and availability of EVs. Range anxiety. Consumers may be hesitate to switch to EVs due to concerns over driving range and charging infrastructures. Solution is educational campaigns, test drive program, range extension solutions. Next, regulatory and policy challenges. Issue is the policy uncertainty. Solution is engage with government bodies and subsidize and tax benefits, compliance with the standards. Next one is customer support and service. Issue is limited service centers. Lack of sufficient services and maintenance centers for EV near Sukna. So solution is expansion of service centers, mobile service units, and training and certification. By addressing these issues, proactively Avera EV can optimize its operators, enhance consumer trust, and accelerate the adoption of EVs in the region around Luna. Thank you for your attention.
Now the last team, that is team number 4. Team number 5 completed. So the team number 4, but we will present now.
Hi,
Bina. I'm B. Srinivas Raju. I'm representing Team 4. Presentation outlines, sessions, field visits, P- agri-workers. Agri-PV systems are engineered to integrate solar energy generation with agriculture practices on the same land. Below are technical aspects and design considerations that ensure the efficiency and the practicability. System component types: semi-transparent PV panels for better lighting distributions, beneficial PV panels for capturing light on both sides. Power ratings: typical range of 250 watts to 600 watts per panel. Tilt angles optimized based on latitude and crop requirements. Standard PV panels are used. Mounting structures: elevating frames, height technically 2 to 4 meters of tractor axis. Single axis or dual axis trackers increase the solar energy capture by 10 to 30%. Fixed tilt screens economically but less efficiency compared to the tracking systems. Inverters and power electronics convert DC to PV panels to AC for grid for farm usage. Equipped for maximum power point tracking MPPT for efficiency. Energy storages battery systems for off-grid farms or nighttime uses. Technologies: lithium-ion, lead acid or flow batteries. Monitoring system: sensor for soil monitoring, temperature, light intensity. IoT enabled systems for real-life data collection and system control. Land use optimization. First one, panel arrangement. Row spacing: 8 to 12 meters to ensure sufficient sunlight for crops. Orientation: east to west for uniform steering, north south for optimal solar energy. Second one, steering management. Panels are designed to allow partial steering. Adjustable tilt systems can be modulus reading levels to balance energy and crop needs. Crop selection: safe tolerant crops such as vegetables, fruits, herbs, medicinal plants and fodder. Electrical specifications. PV system size varies from a few kilowatt to small farms to LW scale for large operations. Voltage level: low voltage up to 1 kilowatt for small systems integrated with PV structure. Rainwater harvesting collecting through tilted plants, storage in underground or above ground tanks. Climate considerations. Windows structures must be designed to withstand local wind speed. Temperature: heat resistance crops are selected for high temperature regions. Environmental impact: dual use efficiency (DUE) measure of the combined efficiency of the energy production of crop yield. Land use efficiency typically 60 to 80% higher compared to the standalone systems. Carbon offset: a big reduction in CO2 emission due to renewable energy generation. Standard and guidelines. IEC standards: IEC 61730 for PV modulation safety. IEC 62817 for PV tracking system. Architectural guidelines. Adaptation to local farming practices and climate conditions. PV in agriculture. Electrical vehicles are gaining traction in agriculture where they can produce sustainable and cost-efficient solutions for various farming activities. Applications: electric tractors and machinery. Electric tractors and machinery are replacing traditional diesel-powered ones. These machines are quieter, more efficient, and produce zero tailpipe emissions. Examples: autom autonomous electric traction for precision farming, electric plows, seeders, and sprayers. Second one, transport and logistics. EVs such as electric vans, utility vehicles, and trucks are used for transporting goods, livestock, and agriculture produce between the outside farms. Compact electrical vehicles are also used on farm logistics like moving supplies or harvesting crops. Third one, irrigation systems. EV can power mobile irrigation systems allowing farming to efficiently manage water usage. Integrated EVs with solar charge batteries are also used
innovation operations. Fourth one, drones. Electrical drones are widely used for aerial monitoring, crop health, pesticide spraying, and field management. Integration with renewable energy. Agrivoltaic system. Combining EVs with agrivoltaics allows farmers to charge EVs using solar energy while benefiting from shade tolerant crops. On-site charging. Farms equipped with renewable energy sources such as wind turbines or solar panels can establish charging stations for EVs, reducing reliance on grid electricity. Benefits of EVs in agriculture. Environmental benefits. Reduction in greenhouse gases emission compared to diesel powered machineries. Lifespan and farm workers. Cost efficiency. Low operations and maintenance costs due to fewer moving parts in EVs. Potential savings on fuel by using renewable energy for charging. Improved productivity. Precision and automation. Electric powered systems such as integrated better with modern precision agriculture technologies such as GPS, IoT for optimization farming operations. Increased efficiency. High torque capabilities for EVs enhanced performance for tasks like plowing, hauling heavy loads. Avaria. Vera EV near Nunna is a company like involved in the development or distribution of electrical vehicles. As an emerging sector, the EVs industry faces various challenges. First one, supply chain and component production. Issues, shortage of raw materials. EVs requires key materials such as lithium, cobalt, nickel for batteries, which might be challenging to source. Logistical challenges. Distribution delays in acquiring critical components, especially from international markets. Solution, local sourcing, uh, diversified supply, stock management. Charging infrastructure issues, lack of charging stations, slow charging time. Solutions, collaboration with local governments, partnership with energy providers, fast charging solutions. Third one, market competition, increased competition. As the EV market grows, EV might face intense competition from other domestic and international EV manufacturers. Solution, product differentiation. Focus on unique selling points like vehicle range, battery life, innovation design, or added features. Customer-centric approach. Focus on after-sales service, warranties, affordable pricing strategies, brand loyalty, strengthening brand value through customers engagement, feedback loops, and community-driven innovations. Fourth one, technology and research. Issue, battery technology
Dear participants, thank you all of you to share your knowledge to the this particular FDP. So let me explain how you have written the Atal program. That is, so you have conducted two programs. So the first one is a basic Atal FDP in the year 2023. So that is also on electrical vehicles. So the how to use the electrical vehicle to get the sustainable energy. So that is we have conducted that FDP in the year 2023. After that, we conducted one more FDP that is on so the AST sponsor, that is a one scheme. So that is also electrical vehicles. So then the year 2024. So when I'm writing so the proposal to the AICTE, so always I am writing on electrical vehicles. Now, so this time I would like to write so the proposal on electrical vehicles in addition to the agri PV systems. So this actually that is more than 3,000 applications are received by AICTE. So the only 50 proposals are accepted under the advanced Atal FTP. So I am very thankful to the AICTE and the expert committee to accepting my proposal so the on electrical vehicles and agri PV systems. So that is one thing. So I think these 12 days program we have gained so the knowledge on electrical vehicles and agri PV systems. So that this knowledge is useful for doing the so the or writing the papers, research papers in the scope of general papers and SCI like that. So the here my suggestion is agri PV systems. The limited number of publications are there. If you open the Scopus database, there you can see the so only so the 100 the papers are below 100. So therefore, if you write something, so the by using the optimization algorithm, that is a what you call TLBO or genetic algorithm, if you want to optimize the tilting angle like that, so you are able to produce a more number of papers on agri PV systems. That is a and also the many issues are there with the agriculture. So the one way you can do the projects or any research papers writing is on the using the drone technology. Drone technology actually I don't have any idea about the drone technology. So after attending this FDP, because of research persons are from an all NIT, so the I learned lot from the research persons how to use the drone for the agriculture purpose. So there you can there are more number of chances are there to do the research work in the drone technology. So that is a one I can say that is a one outcome of for this particular FDP. And then we explained our research persons are explained. So all the concepts are related to agri PV systems. In AP, there is no agri PV systems, agri PV systems. So as a research person, I explained so the different agri PV systems in India. So the finally we can conclude that agri PV systems are not available in the Andhra Pradesh. Okay, that is a key point. Key point in this FDP. So the next one is after this session. Okay, now you can take the break. After that, you can come. You can see the reflection general. The validity starts sharp 4 o'clock. After that, you can leave. So the thank you all of you your active participation.